All right, welcome. Today's welcome to today's YouTube presentation. My name is George. I'm a mentor on the GATS program for 2020, Google Africa Developer Scholarship Program. I'll be looking at architecting with Kubernetes, and this eighth in the series, number 8 in the series, we'll be deploying Kubernetes engine via Helms charts. Okay, so of course, as usual, your timer's here. The button to start the lab is here. You first of all flip through, look through the instructions before you go ahead and start the lab. So the normal process, and of course, the normal warnings, we should use an incognito window and should use the credentials that will be provided for us to log in into the console when we launch the console. If you use any other accounts, that account might be charged. Okay, so once we're in there, we activate the Cloud Shell and would set some parameters. You can skip all this. Of course, you can also go through that too. So the second task, named number 1 here, task 1, use Helm charts to deploy GK cluster. We will use the Helm to do that, create a deployment manifest for a pod inside a cluster. And what again? Let's see, do we have any other tasks? No, so they're just 2 tasks. So this is basically a very quick one. Okay, so let's quickly start the lab so that we don't take much of the time. Okay, so I'll put my, okay, the lab, the console is ready to be opened. Okay, so I'll place it here on the first task, and I'll open that. So let me copy my username from here, pastes, and goes through, and copy the password from here, paste here, and of course hit the enter key, and it goes forward. Accept these terms. And then again, of course, like I said in earlier videos, you don't need to update anything concerning this account. It's not yours. Setup is a temporary account set up by Quick Labs just for this lab session. All you need to do is confirm, and you move to the next window, and we'll be ready to begin our lab. Okay, so give it a few minutes. Okay, so lab is back. Okay, we accept this. You don't need to do this. Remember, the email isn't yours, so that isn't really necessary. So just accept terms and we're ready. Okay, first thing we're asked to do is to activate the Cloud Shell. So let's do that. Click continue, go back and check the instructions again. Okay, so let's read through here. It says, this task, you use Helm charts to deploy Kubernetes engine clusters. Typically, Kubernetes systems consist of many different resources. Though you could maintain configuration files for each of these resources, managing versions of different resources and compatibility among those versions can be difficult. Helm is a popular tool used with Kubernetes for packaging resources. Okay, like explained in the previous the video before this lab, we have different package managers on Linux used to install on Windows. They have, I think, Chocolatey. Mac has, I think, Homebrew. So in terms with regards to Kubernetes, its own packet manager is Helm. Of course, Helm doesn't come pre-installed with Kubernetes. You have to install it and have it use it to be able to install all the packages, and helps you manage things here and there. Okay, so we create a deployment manifest for a pod inside the cluster. Create a GKE cluster in Cloud Shell. Type the following commands to set the environment variable for the zone and the cluster name. Of course, this right here, export my zone equals US Central A, is a method in Linux or Unix systems where you set the environmental variable in that particular window. So we're creating a variable called my zone, and another one called my cluster, each holding the values US Central 1A and standard cluster 1 respectively. Now this will only be set for that particular shell. If you were to close the shell and reopen it, then you need to run these commands again. Okay, so I will quickly just click here to select both and then paste it in my terminal. That has been set. Configure Kubernetes kubectl tab completion in the shell. It makes it easy for you to type commands and get auto completion. Okay, I use that a lot because there are a lot of commands that I don't remember, so I use that to forget something. I simply type G Cloud and double tab, and options will be presented to me. Okay, so in Cloud Shell, type the following command to create a Kubernetes cluster. Let's look at this command: G Cloud container clusters. This is the G Cloud container clusters. Create my cluster. The number of nodes initially with 3, and you enable IP alias and place it in the zone which we had previously set here. Okay, all right, so we'll click on that, we'll come here and we'll drop that there. So that will take a bit time to get ready. Let's go to the 4th step in task 1. It said in Cloud Shell, configure access to your cluster for kubectl command line 2. Of course, after creating a cluster, you need to set the context for your kubectl commands, and setting the context here is simply telling kubectl which cluster you want it to direct all the subsequent commands you'll be running with it to. It gets the credentials of that cluster and makes it available, and then you can run your commands against that cluster. So our cluster is still coming up. Of course, if you want to see that live, you could go to Kubernetes Engine and click on clusters. When you do that, you should be able to see the cluster being created. Of course, this part has to do with tutorials to help you understand Kubernetes better and the rest. So you can right click and open a new tab after the lab. You can, of course, look through it. So a standard cluster 1 is still being created. So wait a bit. Okay. Right. So meanwhile, let's go through the other instructions. So download the Helm binary, deploy a Helm chart. So use the curl command. This command is used to retrieve documents online and to your current location. So in this case, we will retrieving the get Helm file that we'll be using to install Helm, and then using that to run Helm against our cluster. Of course, in Linux, executable files used for installing applications I usually have an extension of sh. We have others. We have run. In Linux, it doesn't really matter the extension, but there's a convention where you use sh to represent a file that is to be used to install something. Okay, so let's go back and check. It's still installing. Okay, so this file, after you bring it in using the curl command, you will need to make it executable by running change mod 700 against that file. When you do that, this file will now be executable. If you don't do that, you can't execute this file. That's the way Linux works. Okay, so the file comes in as an ordinary file, then you make it executable, then you run it. And of course, you need to run it with the period / get Helm from the current directory. This is how you run it. If you were doing it from another directory, you would append this command to the path to this location. So we're doing it in our current location, so we don't need to append any path to it. After that, we will ensure the account has cluster admin role. We will create a cluster role binding. Role here is cluster admin, and we add ourselves to that role so that we can play around with that with the cluster. Okay. All right. So that's been set up. Let's do the next thing, which is to bring in Helm. No, not Helm. We will first of all set this, get the credentials for our cluster, then click on that, take that. Okay, so all right, so let's take that. Okay, so if you type ls to list the contents of this current location, you see get helm, get underscore helm.sh is available. Okay, so let's make it executable. You click on that. You could also type it. I advise you do if you're not very familiar with Linux commands. Okay, so let's run that uh, installer and install Helm on our system. Okay, all right, so that has been installed. Now we add ourselves to the role cluster admin. Okay, all right, okay, all right, so okay. All right, so create a Kubernetes service account that is Tila. The server side of Helm can be used for deploying chats. Okay, so this is the server side of Helm. So we're using kubectl to do that. Okay, not to do that, sorry. We actually need to create a service account. Okay, of course they said here we should create a service account. Okay, that's all right. So use kubectl to create a service account called Tyler and place it in the namespace, kube system. That namespace is comes pre-created by Kubernetes. So we're adding the service account to that namespace. Okay, so namespace is simply a way of grouping resources so that it's easier to manage. Okay, so we've added our service account, then we'll grant TILA service account, the cluster role admin, just as we had done previously for ourselves. Okay, so let's see, enter here. Okay, so that's done. Now we execute this command to initialize Helm using the Tila service account. Okay, so that gives Helm access to your cluster. As a result of the cluster admin role, we added the Tila service account to. So Helm will be using that service account to run commands against your cluster. Okay, so let's check our progress. You click on this. Okay, that's good. Now execute the following commands to update the Helm's repository. Okay, so we are beginning to use the Helm commands. So let's use that. Let's see how to update that and see what will happen. Okay, so that's been done. Let's check the Helm's version. Okay, we'll drop that here. All right, so 2.16.9. The client is this version, the server is this version. Okay. So of course we have a client, we have a server. All right, so executes the following command to deploy a set of resources to create a Redis service on the active context cluster. Okay, so we're installing Redis, right? Okay, so as Redis has been installed, okay. All right, so a Helm chart is a package of resource configuration files along with configurable parameters. This single command deployed a collection of resources. A Kubernetes service defines a set of pods and a stable endpoint by which network traffic can access those pods. In Cloud Shell, execute the following command to view services that were deployed through the Helms chat. All right, so let's see what Helm. Okay, so we have, okay, all right, so we have this cluster. Okay, cluster, sorry, services. We have the Kubernetes service. We have these three other services that were created by Helm on this port. And of course, service type is cluster IP. All right, so those are the services that were created. All right, let's go down. It says a Kubernetes stateful set manages the deployment and scaling of a set of pods and provides guarantees about the ordering and uniqueness of these pods. In Cloud Shell, execute the following commands to view a stateful set that was deployed through the Helms chat. Of course, stateful sets make it possible for you to store the states of your application. Okay, so two of these were created. All right, so we'll move forward. Say Kubernetes config map lets you storage and manage. I think that should be store and manage configuration artifacts. So that they are decoupled from container image content. In Cloud Shell, execute the following commands to view config maps that were deployed through the Helm chat. Okay, let's see. These configuration maps are used to manage storage. Let's use store and manage configuration artifacts. Okay, so let's see what. Okay, so we have that. I'll check was even created. Okay, so now a Kubernetes secret like a config map lets you store and manage configuration artifacts, but it is specially intended for sensitive information such as passwords and authorization keys. In Cloud Shell executes the following commands to view some of the secret that was deployed through the Helm chat. Okay, so rather than passing in passwords from the terminal, you could set up secrets that will use this. So these are the two things, two secrets that were created. Okay. All right. So let's check our progress once more. Okay, we're good. And you can inspect the Helms chart directly using the following command. Okay, so one of my favorite commands is the Spec Command. It checks a lot, lets you see. Okay, that's the same command used when using Docker images and containers. Okay, so this gives you everything about Helm charts, about the Redis that was installed. Okay, so Redis package that was installed in your cluster. If you want to see the templates that Helm chart deploys, you can use the following command. Okay, dry run here, simply telling this command, it shouldn't do anything. It should just go through and show you what it would normally do if this dry run parameter wasn't passed to the command line. So let's see how that works. Okay, so come down here, we can clear a screen, type clear and hit enter to clear that screen and then hit that. Okay, steps through. Okay, and comes to an end very quickly. Of course, you can see the manifest file from here. From here, see the manifest file. Let's create. All right, volume. Okay, these are volume mounts and volumes. Okay, config files, config map files, volume claims also. These are used when you are creating a stateful application. Okay, so let us test the Redis functionality. You store and retrieve values in the Redis, new Redis deployment running in your Kubernetes cluster. Execute the following command to store the service IP address for the Redis cluster in an environment variable. Okay, so we're running the export command again, and that would create a variable called or named Redis underscore IP. Okay, all right, so it said retrieve the Redis password and store it in an environment variable. Okay, so we run another command and get the password. Okay, okay. Okay, so it actually started here. The manifest file, one of them started here for the Redis state, Redis slave stateful set.yaml. Started from here, PI version, kind, metadata, spec, specification, and the rest. Okay, so you can take a look at that and see what and what were used to create that Redis package. Okay, so display the Redis cluster address and password. Of course, do that, copy that. So run that command. Okay, the cluster IP address is to the second one, and that's the password there. Okay, all right. So it said open an interactive shell to a temporary port, passing in the cluster IP address and password as environment variables. Okay, so that's been stored in these two variables, Redis underscore IP, Redis underscore PW. So that's the IP and the password. We're going to use them in this command to connect to a port, just like we would open our terminal and connect to a Linux machine. So we're connecting to a pod, which is of course a container. And we can connect in this manner and run commands against that container. Okay, so let's do this. See what happens. Okay, hit enter. Oh, I made a mistake there. Okay, hit enter. All right, let's see what happens. If you don't, okay. All right, so I have no name Redis test. Okay, so that's we're in the container right now. Okay, so connect to the Redis cluster. Okay. Okay, so let's use the command line for Redis. All right, warning, using a password with A option on the command line interface may not be safe. Of course, it's no problem, we're just testing. Now set a key value. Okay, so it was set successfully. Let's go over this one more time. We use this command here to connect to the pod. Connect to the pod. Okay, all right. I see. Well, actually, we created a pod on the cluster called Redis test. Okay, so we create a pod and then we connect to that pod interactively so that we can run commands against that pod. Then while in that pod, we run this command to connect to a cluster, to the Redis cluster, and then set a key, and then we let us retrieve that key here. Oh, sorry, I think I made a mistake. Let me run that command again. Connect warning, right, and then set any key. Okay, so I don't need to do that. Let me just simply get the key. Key should be set. All right. All right, so that's the key that has been set, that was set in the Redis server, and you retrieved it using, after setting the key, you now retrieve it using get my key. Of course, the name of the key or the value that was set is my key, and then to get it, you use the same name to get it. So that's about it. We can stop the lab for now. Thank you for watching. If you think it was useful to you, please simply click the like button on the video. Thank you very much.